Alright, hey there, welcome back. I hope you've had a chance to have a little bit of a break. Let's get cracking onto alkenes now. Ha, cracking, alkenes. Funny, I'm such a joker. Haha, I didn't even notice. Um, Obviously, if you remember when we did cracking earlier in this little before the break, um, you would remember that cracking is the way we get alkenes. We take big, long hydrocarbons, and by doing the cracking reaction, we turn them into small alkenes that we can do chemical reactions with. Today we're going to look at the alkenes. We're going to look at them in their homologous series, and we're going to try and have a look at some of the properties that they have. Okay, so alkenes are a new homologous series. So this is a homologous series. Homologous series that contains one C-C double bond in the molecule. So all the alkenes contain somewhere in them a C-C double bond. That's really important. And only one. It only has one double bond. If it has more than one double bond in it, it's not an alkene anymore. We call it, if it's got two, it's called diene. If it's got three, it's called a triene, etc. So let's try and think of what these alkenes could be. Alkenes are named exactly the same as alkanes, except instead of saying ane at the end, we say ene, because it's not an alkane, it's an alkene. So for instance, if I C2H6, which is this, this is called ethane. It is an alkane because there's no double bonds. C2H4, that looks like this. And we call that ethene. This is ethane, this is ethene, because it has this double bond. Now remember, every single carbon atom, we said this previously, every single carbon atom needs to have 4 bonds. Let's count the lines connected to each carbon atom. So let's go for this carbon atom. It's got 1, 2, 3, 4 lines. Remember, that's 2 bonds. And over here, let's try this carbon atom. We've got 1, 2, 3, 4 lines again. So this is perfect. This is perfectly bonded. It's an excellent way of showing the bonding. All right, let's go through the first few alkenes and see if we can spot a pattern of what's going on here. So, obviously we've done ethene already. We've also got propene. We've got butene. We've got pentene. Obviously we'll have hexene, heptene, octene, nonene, decene, etc., etc. as we go through. Propene is going to be C3H6. Butene is going to be C4H8. Pentene, C5H10. Notice the pattern here. The general formula is CnH2n. So it's got a different general formula to that of alkanes. They're not the same general formula. And that's because the double bond kind of takes away 2 of those hydrogen atoms. All right. So what do these look like in displayed? So 1 double bond and then 1 single bond. This can get a little bit confusing. what you have to do is kind of work out how many bonds are left on each of these carbon atoms. This guy here has only had one bond attached to it, so he can have 3 hydrogens. This carbon atom has 1, 2, 3 bonds already attached, so he only needs 1 hydrogen. This guy has 2 bonds attached, so to get to 4 bonds, he needs 2 hydrogens. This is propene. Butene, again, C, double bond, C, C. This one, only 1 bond, that can be 3 hydrogens. Here, 2 bonds, 2 hydrogens. Here, 3 bonds, 1 hydrogen. Here, 2 bonds, 2 hydrogens. Finally, for pentene, C, double bond C, single bond C, single bond C, single bond C. 5 C's in total, only 1 double bond. Here, 3 hydrogens. Here 2. Here 2. Now this one contains 3 bonds, so only 1 hydrogen. And here we have 2 hydrogens connected to this one. Alright, in that ball and stick model then, in your ball and stick model you still need to show the double bond. So you've got to draw 2 lines for that double bond. Then we go like this. Boom, 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 boom. Okay. Right. For the next one, show the double bond. Got 4 of these guys. 1, 2, 3. 1, 2. 1, 1, 2. Here for pentene, sorry. Again, show the double bond. Doop, doop, doop. So there's 5 there. 3 on that first one. Got 2 on the second. 2 on that third one. Just 1 on the second to last one. And then 2 over here. And here's our structures of propene, butene, and pentene. Alright, let's have a look at some of the chemical reactions that these guys can do then. So, alkenes also do combustion reactions. So if you remember those combustion reactions that we did back when we were doing fuels in C20, they're exactly the same for the alkenes. Let's just do a really simple one. Let's do butene. So we've got C4H8 plus O2. What are the products of a combustion reaction again? Hopefully you remembered. It makes carbon dioxide and water. Now this isn't complete, we need to do balancing. So we've got 4 here, so that means I need 4 of these. I've got 8 here. Again, I'm going to need 4 of these, because 8 divided by 2 is going to be 4. Let's count up all my oxygens. I've got 1, 2, 3, 4, 5, 6, 7, 8. And here I've got 1, 2, 3, 4. So 8 plus 4, 8, 9, 10, 11, 12. So I've got 12 O atoms. Well, I've got an O2 over here, so 12 into 2 is 6. So this is my balanced equation. C4H8 plus 6 O2s makes 4 CO2 plus 4 H2O. Nice, easy balancing equation then. Something else that's really interesting is alkanes can also do addition reactions. Now, alkanes will do addition reactions to make things like alcohol. We can make alcohol out of ethane by reacting it with water, or we can add halogens to it. It reacts with halogens and kind of makes the color of those halogens disappear to make halogenoalkanes. Let's have a look at both of those reactions. So, if I react ethane, with steam, and I'm going to need to use a catalyst for this. If I do this reaction with a catalyst, then what you get is that water adds across the double bond. So that double bond opens up, it sort of breaks apart the double bond, and one of the hydrogens from the water will go here, and the OH from the other side of the water will go here, and will make a chemical called ethanol. You can imagine if I draw this out and displayed, I've got OH. What's basically happening is that this bit here is getting added on here, and this bit here is getting added on there. So you can see where those bits have kind of added on to the molecule, and because they're added on, this is obviously called an addition reaction. Okay. Let's look at the other addition reaction, which is creating haloalkanes or halogenoalkanes. Again, let's do this with ethene. So here's my ethene molecule. And let's react it with a halogen like chlorine. Well, again, we're going to break this double bond, and the chlorine, half the chlorine is going to go to one side and half the chlorine is going to go to the other. So what we make is CHH, CHH. We've broken the double bond. We're going to have one of the chlorine atoms here and one of the chlorine atoms there. Again, hopefully you can see this. We break this double bond here. If I draw this out in displayed, then this chlorine atom is going to end up here, and this chlorine atom is going to end up there. So you can see that those chlorine atoms have just reacted with this, and they've sort of added on. And because they've added on, this is an addition reaction. This, of course, works with any halogen. So really commonly, we actually use bromine. It's a very, very common reaction. You've probably done it in class yourselves. When you react an ethene, any alkene in fact, with bromine, it's a really good test to see if it is a alkene. It's the common test that we use to check for alkenes, because the bromine will disappear and it will become this dibromoethane. You can see that the bromine here is just added across that double bond, forming an addition reaction. Now, so this is used in a test to test for alkenes. Add a little bit of orange, yellow bromine water and shake. If it goes colorless, it is an alkene. If it stays orange-yellow, it is not alkene. So this is a really good way of testing to see if something is an alkene or not. It's really easy to do in practice. Say if you've got a sample of alkane and alkene. So if you just have your test tubes like this, and you've got an alkane and an alkene in here. Alkanes and alkenes are both colorless liquids. You add some bromine water into both. Add some bromine water into both. One of them should stay yellow, the other one will go colorless. So this one is the alkane, and this one is the alkene. There you go. All right. Thank you very much, guys. In the next one, we'll look at isomerism.